When you apply a foliar application of ionic calcium, when it lands on the leaf surface, does not move from those leaves, out of the leaves and back down the stem or the branch and into the fruit. And this doesn't matter if we're talking about tree fruit or grain crops, it's all the same principle. So in order for calcium to be mobile and to move out of the leaves as a foliar application into the seeds or the grain or the fruit, it's required that that calcium be in a chelated or complex form. So this is why when we put on foliar applications of, let's say, calcium nitrate or calcium chloride, or anything where the calcium remains in its ionic form, it gets absorbed into the leaf quite effectively, but it doesn't move from the leaf into the fruit or the grain, which is a really big deal if your objective is to improve fruit quality. So for that reason, foliar applications of calcium need to be chelated, and they need to be chelated with chelation elements that move through the phloem quite readily. And there are a few. This is one thing that we spent a lot of time researching when we were developing our rebound line of trace minerals. There's a very short list of chelation agents that are effective at moving nutrients from the leaf, not just into the fruit and grain, but all the way down into the root system, which is quite important if we're dealing with soil-borne diseases such as Fusarium or others, where we have trace minerals that can have a powerful effect in producing disease resistance against those diseases, as long as it can be applied as a foliar and moved to the root system. Few chelation materials do that, with the exception of what we put together in our rebound line of trace minerals.